So quite a bit of this has already been added to, and I'm just going to give you the relevant parts. I'll post all the code to you after this. But basically where I want to start is if I'm able to save and load a game, that means it affects the logic of the board as well. So the first thing I'm going to do is make it so someone can load a state into the logic. Then I can think about how that's going to affect saving and loading the file. So first thing I'll do is pull up that logic class, and the only method I've added is this one, being able to load a state. And basically what I want to do is burn through. I'll assume that this person has given me a valid state. So the person who calls this method, it's their responsibility to make sure that this is a valid legal state of the board that I'm loading. But basically what it will do is destroy anything that was currently on the board with these new things. And this is what the logic keeps track of. What are the states of the chips? Are they black chips, white chips? In my case, SOS chips. Whose turn is it playing the game right now? Because when you resume, you would like to resume with the same turn. And what were the scores of the game? So those are the things I would need to be able to update. Otherwise, I'm not going to be able to, I might be able to update what the board looks like, but then I wouldn't be able to update what the rules of the game were at that time. So let's make a few variables here to track this. So for me, the rows is going to be states.length, and the columns, I can pick any row in there. So I might as well pick index 0. Oops, sorry, index 0. This would represent how many columns I have, any of the rows in that 2D array. So I'll pick the first one. Then I'm just going to burn through a nested loop. Where I'll just set those values. So we still have this need for 2D arrays and two-dimensional, well, nested loops, I guess. C++, yeah, that is the joke, by the way. C was the original language, and C++ is one more than C, so nice catch. So in my class, board is what stores the states. So that's what I'm going to update here, is whatever they gave me, and remember, it's their burden to figure out a proper state. I'm assuming it has to be proper, and I'm going to just take on whatever value they did. And if you remember my design, I decided to use buffer chips to make the testing a little easier. So I'm going to add those buffer chips so that I skip them when I'm updating. Okay, but all this does is take the board they handed me and punch in the chips that were there. And then I'm just going to update the turn. So player, whoever's turn you're telling me it is, and the scores on the board are just going to be whatever you gave me. Okay, so again, this just lets me update the rules. So then the next thing we would want to think about doing is how we're going to connect this. So I've decided to do a button class. I'll let you look at the button, but I'll just show you what a button does. You can look through the text on or the code on your own time, but basically the way it acts in a button is it basically just says if someone clicked this, then do the onClick method. And onClick is abstract, which you may not have seen this keyword yet. Abstract, when you declare it, says I'm not the one responsible. A subclass will do this. A subclass could then delegate it to another subclass and another one, but eventually someone has to be responsible for telling you what this does. So you will not be able to ever compile your Java code if you have an abstract class. You can make a reference to an abstract class, but you can never construct or build an abstract object because it's incomplete. But the reason I've done it this way on purpose is this is a generic button. And the abstract method I'm telling you is, if you click this button, what do you want me to do? So the code for what you want me to do when I click on a button is what you would write when you overwrite this method. So let's take a look at that. For example, if I want to save the game, I'm going to create a button whose text just says save, and it's going to access the logic of the game, because I want to know what I'm saving, right? If I don't know what I'm saving, it's kind of useless to me. So someone has to tell me what I'm going to be storing. Okay. And then here's the onClick method. This is the format I've chosen for my files, and that's what I'm going to be writing out to a file so that I'm able to find my code. So let me just grab this. Okay. So the first thing that I would want to do is I would want to know, I would want to be able to pull up from the world what kind of chip that I have. So actually, before we do that, then I'll show you what I did for the world. I just extended the world so I wouldn't have to alter my code. This is the exact same world, but it's a world which can save and load code. So I have added the functions here, everything the superclass does, except I have a method now that places buttons for saving and loading. So all this is adding the buttons to the screen. It's nothing new for you. And I would like to know what chip. I would like to know about the chip. I would like you to tell me stuff like what's there. Is it an S chip, an O chip, so that way I can save it. Because if I don't know what's on the board, then I'm not going to be able to save it. So I need a method that's going to access it. And that's new. So I've added it to this class. And excuse me. This is the method that's going to do all of its magic, I suppose, as far as loading up this view. So we'll come back to this one once we've done the files. But this is the method that I'm going to burn through in that save game. Okay. So I'm going to get the world here. And I need it to be cast so that I can use the methods in that class. A lot of this stuff is what we've already talked about in files. I'm going to continue to use those classes like a print writer. And something new that I've added, and you can have a look at my code later, is I've added a little bit of Java Swing. I'll show you in the demo what it does, but it's just typical Windows file browser, when you want to save something. So once I get the file from that Swing class window, it'll store it here as F. So that's what I'm using to construct my print writer. Okay, so in my game here, the rows that I've got is going to be the state of my game, and I'm going to get how many rows were in how many rows were in my game. Then I'm going to ask that column how many columns there were, and then immediately I'm going to save that to the file. So I'm going to say writer.println rows plus a tab. So I'm using tabs to separate my data. And one other thing I've got in here is how big is each cell that I'm loading, because if I want to reproduce that board, I should know how big to make the squares on that board. So this is what my first line of data is, and that's what I documented here. So first line of the file tells me how many rows and columns I want to build, as well as the size of each cell. I believe in my game it's a 30 by 30 cell. Okay, now I have to loop through the board and get all these chips. So I'm going to say for int row is 0 while row is less than the total on the board. Then let's get the board that I'm at. So I'll get the chip that's by its row and column, and then I'm just going to use this little handy method here to do it for me. So writer.print that chip, I can get the class from it and then ask for its simple name. So this will basically give you the name of your class. The simple name, it omits all of the package names that's part of it. Like for example, Greenfoot.actor. you know, however you would resolve your class. In this case, it'll just give you the name, and that's all I need. Okay, so this is going to give me the row of objects, the chip here. It's going to start separating them by tabs until I'm done. So when I get to the end of that, I want to go to a new line. So I'm going to go to this writer object and just print an empty line to advance it. So at the end of this nested loop, I will have spit out every type of chip on my board. And then I just have to follow up with a couple other pieces. Like I'm going to ask, whose turn is it right now? And I'm going to ask, what are the scores? Because I definitely have to save the scores. The game that I've chosen to do with you is actually a fair bit challenging to save these states. Some games, you can just use the parity to know whose turn it is. Like, for example, if it's alternating every time, if there's 3 chips on the board, you know it's still player number 2's turn, because you're about to place chip 4. So you could resolve that without needing to save it. But in my game, your turn gets repeated, so there's no way to reconstruct it simply other than just to save it. Again, it's another complicated task of who claimed the rows and columns. So I'm just going to save that stuff. In today's day and age of terabytes, it's really not a significant concern for you to be, you know, cheap with your data. You can save states rather than trying to figure out what it is from the data you were given. So this will pump out a file now when I try to save the game, and I'll show you what happens, but it's incomplete at the moment. Oops, what did I forget here? Illegal character. Oh, I forgot a closing one here. Okay, and right, my class is still incomplete, so let's do the load game. So again, I'll just show you the part of the code that I would have had to write to come up with loading it from file, which is basically undoing the method we just talked about. So I'll show you how that works. I'll stick with the scanner like we did with your file exercises. And I'll scan the file. And remembering that the format, this should also have the cell size on it, is just here as a reminder to me, and I'll show you how I punch that in. So I still like the format of reading lines at a time. And using my, my split method. So my tokens that I'm going to get from this is whenever I go and ask for that line to be split. And it's the tab character that separates my tokens. So this will give me that first line, and then now I'll know how many rows, how many columns, and etc. are in there. I'm reading strings. This is a little method that'll turn it into ints for me. So I'm going to call this up as int rows. Excuse me. It's going to call on my toInt method, and that's the first token on line 1. This is the second token on line 1. And of course, you know, one thing to think about here is we have to assume that we're using a file with the proper format, because if I'm asking for tokens that don't exist, I'm going to crash the program here. For our purposes, I want to see you manipulate the files, but again, this is not very robust. If somebody changed the file format or tried to open a file that was not part of this game, the program would crash. So we'll assume here that we're using the proper format. Okay, so now I need a board that I'm going to create. And I know how many rows and columns I need now, so I can do that. So here's my 2D board, and now I'm going to go through putting the chips on the board. Okay, so again, my preferred parsing here for files is just to continue to read line at a time. So just call on the next line method, and then I'll deal with the tokens by splitting on the tab character. You don't have to use tabs. You could pick something else, but try to pick something that, of course, is not going to be included as data in your file. So if the tokens that I'm looking at is equal, and this is how I call up the names without having to, micromanage those codes. I'll ask for that class and its simple name. So in this case, I'm just using the class itself rather than having to keep track of what all those strings really are. In this case, I know that the board at that row and column has to be an empty chip. So this is going to be repeated for all the different chips that could be on the board. So I'm going to do a little copy and paste here. And it looks like I have 7 cases to deal with. So there's the 6. So depending on your game, you probably have less tokens, less chips to deal with than the one that I've chosen. But other than empty chips, it could be a white chip. It could be a blue chip. It could be an O white. And it could be an O blue. You had a question there?
I'm just trying to get through the logic.
Yeah, I'll show you it again in a second. Let me just, it's hard to code and explain. So I forgot gray. You could also have an S gray. And the only other chip on the board, I'm going to make this an else statement. The only chip it could be is a gray chip after this, so an O gray. There's no other chip in the view that I could place on this board. So is it this that you want to talk about? The logic?
No, I meant like he's just comparing. Not really explain. You just wondering how. Okay, good.
Okay, so when I save the game, it prints each line is going to be what kind of chip it is, separated by a tab. So that's what I'm pulling up here, is I'm pulling up the line, splitting it on a tab, and finding out, does this string, which represents the name of the chip, is it equal to the possible things on the board? The possible things are empty chips, S chips, O chips. These are the 7 chips in my game. Okay. So after this, my board will actually look like the board it's supposed to be. I would see the visual of it, but I haven't actually updated the state yet. So that's what we still need to do here. So after I've spat out all of the chips in that file, the next thing I do is I put a line that has whose turn it was. Okay, so this is where I just finished. I'm about to read this line back into the game. And that's what I've done by assigning the player to that. And then the last line I'm reading back into the game is this one, which has the 2 scores. So let's read the next line off. And the tokens this time. So I'll do it in place like this. Okay, so those are my states that I have to now tell the world about. So now that I've read it in from the file, I'm going to tell Greenfoot to set the world to this new one. Okay, so that's the last thing I need to do to connect up the file. Is now that I've taken all this information in, let's create this view on the board. Okay. So the idea behind this method, it's static because anyone can call upon it to create a new world. You give me a bunch of the data and I will tell you what the new SOS world would look like. So we're still going to need to know about rows and columns. It's possible that you send this data in a method, but I can figure it out by the board they give me. So I'll do the same thing I did before. And this is the world that I'm going to create. And I give it the rows, columns, and the cell size is one of the parameters in my game here. Now I'm going to need to update the state. So I've created a board, I need to update the state. And this will be the nested loop. And in here, since I know the row and column, I want to know where that is. So I'll ask that world, what is that pixel location of this column? And similarly for the Y pixel, but I'm asking for the Y from its row. And that new world, I will add the object at row, column, and X, Y. So this is drawing the chips on the board here. And if that board that I just did is an empty chip, that's the state that I'm going to save. Sorry, it should be a constant here. Okay, and the other possible ones are that it could be an O chip and it could be an S chip. So at this point, the only other thing it could be is an S chip, so I'll just use an else to get me there. So in this part, now I know the world has drawn that board and the logic has been updated. So I'm going to now ask that world to tell the controller to load the state I just created. Now, another thing is once I've done that, I have to redraw it. So I'll use that update scores method from the parent class. And then I'll say this is the world that was just created from all that information. So after all that, Should have an equal sign there. Oh. Okay, so there, see what I've got here. Missing a bracket, which means I'm probably missing a bracket on most of these then. Okay, so now I've got a game I can at least demo and show you what happens. So when I run this game, I'll just do a little test run for you. So here's my SOS, and then O. So here will be a gray one, and then let's put some other chips that don't have any colors. So if I click on save, then this is the dialog that I was telling you about, and I'll call this my game .text. And then I'll go and show you the contents that are pumped out of this. So the tabbing, of course, this is not quite as wide, but Java doesn't really care that this is not visually lined up. Java will still read it properly because it separates them by tabs. But here's the board and cell size. It's player 2's turn. Here's the scores for the 2 players. Empty chips, you've got blue chips, white chips, blue, gray. So this is what I'm going to now parse back into the game. So what I'll do is I'll reset it. And now I'm going to load this game back in. So back here, I'll say here's my game. And now it's come back to life. Again, score 1-1. And it's player 2's turn. If you remember in the file, the 2 was highlighted. Whoops. So what I'm going to do is if I place an S here, it should go gray because the 2 just claimed it. Score was for 2. So this is what I would like to see from your game when you're done, is you can save the state and pull it back in to resume a game.